Hello everyone, and welcome to another GIS mathematics lecture video. And in this video, I want to answer what would hopefully be a fairly straightforward question of does the red point, right, P, fall inside the polygon, the green polygon, right? Is this point inside of this square? Now, visually, right, this is immediate. Well, of course it is, right? But how does a GIS system figure this out? And that's what we're going to go through in this video. And we're going to say, so we're going to have the polygon. So we're going to have polygon A, B, C, D. And we're going to have point P. So the first thing that your computer is going to do is going to be done in a series of steps. But the first thing is going to be just, does P fall in what we call the bounding box of the polygon? Right, and in this case, it's kind of a little odd because our bounding box is actually the polygon, right? So the bounding box, right, this is just the box made by max x, or I should say by x max, x min, y max, and y min. Now, what do these mean? Right, x max, right? If you were to look at all of the points in your polygon, what is the largest x coordinates? That's what x max is. So actually, let's go ahead and label that. Right. So x max, largest x coordinate in your polygon. Right. X min, sort of logically then, is the smallest x chord in your polygon. Right, so then we can sort of imagine that y max and y min are going to fall in that same category. Y max is largest y chord, and then y min is the largest, or sorry, not largest, I'm sorry, minimum is smallest. It's the smallest y chord. Okay, so basically what we're saying is this is going to look exactly like how we did the point intersections in the previous videos, right? We have something that looks like this, right? X min is less than P sub x, or I should say x sub P, right? This is the x coordinate of the point, is less than or equal to x max. Right? So this is saying, does the x coordinate fall within the x range of the bounding box of the polygon? And the same thing is, does y min fall within y sub P less than y max? Right? So if either one of these is false, right? If either one of these is false, we can just stop. We know for a fact that there is no way the point will be inside of the polygon. So let's go ahead and check this against our actual data. Right, so in our case, right, our x min is going to be 1, right? That's our smallest x value. And then our x max is going to be 4, right? That's our largest x value. And our px is going to be 2. So if we sort of scroll down a little bit, right, we said our x min was 1. we said our xp was 2, and we said that our x max was 4. Right? 1 is less than 2, 2 is less than 4. This checks out. Then we do the y's. So if we go back up here, right, our lowest y is 3, and our highest y in this case is 5. Oh, that should actually be a 5. That is actually a typo in the example. This should be a 5. Our highest y is 5, and the y of p is 4. Let's go ahead and let's do that. So is 3 less than or equal to 4 less than or equal to 5? And again, we're going to run through 3 less than 4, yes. 4 less than 5, yes. Check. So now that we know the point is inside of the bounding box, and then in the next example, we'll show you how it can be inside of the bounding box, but not inside of the polygon. So the next thing that we want to do is figure out, okay, now that we know that it's inside of the bounding box. All right, so does P fall inside of the bounding box? That's question 1. Question 2. And this question is going to seem a little awkward, but when we look at another example, it'll make more sense. How many lines are to the right of our point? Right, so how many lines are to the right of our point? What does that mean? Well, that means 1, we can completely ignore the y coordinate for the rest of this video, right? How many points are to the right? So that means how many points, or put another way, right? How many line segments have an x value greater than our point? So let's take a look at how we would answer this. The way that you would approach this, right, is we would turn P, the point, into a line. We would draw an imaginary line, or actually in your case of your computer, right, you would draw an actual line, right? A line that goes like this, extends to the right, it's horizontal to some new point, right? Some new point that I'm going to call point Q. Now Q is going to have the x value of 2, right? It's going to pull the x value from this point because it's a horizontal line. Or sorry, it's going to pull the y value from this point. It's going to pull the y value from this point because it's a horizontal line. It's going to have a 4 in the y. The x value, you can really go anywhere up to and including the x max of the bounding box. So this is going to be x max of the bounding box. So Q is going to have a coordinate of 4 because we're pulling the 4 from the point, and then its x value is going to be 4, which is the x coordinate of the bounding box. So now basically what we have to do is we have to figure out how many lines, right, let's write this in white. So we have to answer the question. Right? How many lines does PQ intersect? This question, right? How many lines does PQ intersect? Right, this is the same question as how many lines are to the right of our point. Right? These two questions, those two questions are the same thing. So how do we go about answering that question? What I'm going to do is I'm actually going to stop this video here, and we're going to continue this in the next video. So if any of this doesn't make sense, right, if how we got from the point P to the line segment PQ, how we got the coordinates of Q as 4, 4, or if how many lines are to the right of point P is the same question as how many lines does PQ intersect. If those don't make sense, pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.